Good evening, class. My name is Abraham Zamaripa, and this is my final art history project. My most valuable player for this course was the Roman Pantheon. For my final project, I wanted to use that monumental structure as a springboard to explore one of the greatest engineering challenges in ancient history: how to enclose massive open dome spaces without the use of modern steel. Specifically, we will be conducting a comparative analysis of the structural mechanics, historical context, and spiritual iconography of the Roman Pantheon and the Byzantine Hagia Sophia. Let's begin with the Roman Pantheon. Completed around 125 CE, Common Era, under the reign of Emperor Hadrian, the building's design is heavily debated, though many historians attribute its structural genius to Apollodorus of Damascus, a brilliant Syrian Greek engineer. From the outside, the building is intentionally deceptive. It presents a traditional rectangular Greek portico and massive granite columns. However, this standard facade hides a radical architectural leap behind it: a massive circular brick rotunda. Historically, while this functioned as a temple dedicated to all the Roman gods, its true purpose was to serve as a physical manifestation of the Roman Empire's wealth, administrative ability, and total engineering dominance. Stepping into the interior, the formal elements reveal a pattern of mathematically perfect balanced geometry. The interior volume is essentially a perfect square. A perfect sphere, resting inside a massive cylinder. The height from the floor to the highest point of the ceiling is exactly equal to the room's diameter, 142 feet. The iconography of the ceiling of the Pantheon is built directly into its architecture. At the apex of the dome is a 27-foot wide opening called the oculus. Because the oculus is completely open to the elements, it allows a single beam of sunlight to track across the floor like a massive sundial, representing the all-seeing eye of the heavens and tying the emperor directly to the cosmos. As a cross-section diagram shows, the primary innovation here is the Romans' masterful understanding of structural dead load and unreinforced concrete. To prevent the massive dome from collapsing outward, the engineers continuously altered the concrete aggregate recipe as they built upward. They utilized heavy, dense travertine rock at the foundation to handle the immense compression forces. As the dome rises, the aggregate transitions to a lighter tufa, and finally to highly porous, incredibly light pumice stone near the oculus. Furthermore, they carved out square panels in the ceiling called coffers, which stripped away thousands of pounds of dead weight without sacrificing structural integrity. Even today, it remains the largest unreinforced concrete dome in the world. Fast forwarding 4 centuries to the Byzantine Empire, we see a completely different structural approach with the Hagia Sophia, built in Constantinople, modern-day Istanbul, between 532 and 537 CE, Common Era. The historical context here is born out of crisis. Emperor Justinian commissioned this insanely expensive church immediately after the devastating Nika riots had burned down half the city. To prove his divine right rule, Justinian bypassed traditional builders and hired 2 scientists, Anthemius of Tralles, a geometer, and Isidore of Miletus, a physicist. Together they executed a rapid 5-year construction project meant to reestablish Justinian's total political and spiritual dominance. Stepping into the interior of Hagia Sophia, we experience a massive central place that completely breaks away from the Roman model. Because of Byzantine theological aesthetics, the iconography relies entirely on natural light and raw reflective materials. Rather than solid physical statues, the base of the central dome is pierced with 40 closely spaced windows. When sunlight pours in and reflects off the millions of the gold mosaics as the structure supports vanish into shadow. This creates an intentional optical illusion where the heavy stone dome appears completely weightless, suspending from heaven by a golden chain. The light itself is acting as iconography, representing God's divine wisdom washing over the congregation. The engineering blueprint reveals the monumental innovation that and Isidore invented to make this layout possible. The pendative, where the Pantheon is a simple round dome sitting on a round drum, the Hagia Sophia forces a massive round dome to float directly over the square floor plan. Pendatives are the heavy, curved, immense weight of the dome down. Pendatives are the heavy, curved, triangular vaults visible in the diagram that smoothly transition that outward thrust and immense weight of the dome down onto four massive masonry piers at the corners of the room. To absorb the remaining lateral forces, they engineered a cascading system of half domes acting as buttresses, pushing the weight safely to the ground and keeping the central space completely open. In conclusion, both the Pantheon and the Hagia Sophia revolutionized how human civilizations constructs sacred space. The Romans perfected material density and concrete mathematics to create a static, perfect sphere representing earthly power. The Byzantine scientists invented the structural pendative to manage lateral thrust, floating a dome over an open basilica to represent heavenly light. Both stand today as ultimate testaments to architectural ingenuity. Thank you for watching. And I am sorry for my voice. I have been extremely sick for the past couple of days. Thank you guys for watching until the end. I had to pause a couple times to drink some water and cough. But thank you guys.